Okay, so we've covered the first set of basics about logic, um, trying to make sure we understand the difference between an argument and other types of statements, and then the pieces of an argument, which are relatively simple. They involve two basic pieces, a premise and conclusion. Now, oftentimes there's more than one premise, and as you'll see later as we get deeper into the class, the conclusion itself can become a premise for another argument when we extend our arguments, which often happens in daily life, whether it be in business or at the school or wherever. So this unit, we're going to focus on understanding the difference between a deductive argument and an inductive argument, and also the types of arguments that fit into those categories. All right, so deductive, inductive, two separate parts, and under each are types. So, and there's going to be an opportunity for you to practice this and see how you do at guessing or figuring out, hopefully not guessing if I do a good enough job, but figuring out which is which and what type they are. All right, let's put this over here. All right, so basically the difference between an inductive and a deductive argument has to do with necessity versus probability. All right, so a deductive argument is necessarily true, right? If the premises are true, then the conclusion has to be true, and you're going to see some examples of that in just a bit. An inductive argument, however, is not necessarily true. It's probably true. And inductive arguments are probably more common in daily life than deductive arguments. And you'll see that deductive arguments fit into certain categories like math and science and other things where we're actually arguing about facts, right? We're making arguments built out of facts. We're not arguing about facts. We're making arguments built out of facts. And therefore, if the facts are correct, the conclusion has to be, it necessarily has to be. But a lot of arguments, a lot of logic is used in arguments that are probably true. And then it's really, we argue about the degree of probability, all right? So hopefully that gives you a basis for understanding deductive versus inductive arguments. So let me they can be tricky, all right? They really can be, it can be more difficult than you think. So I wanted to use another diagram here. I can't get out of the way. Can't get out of my own way. That's not different. So inductive or deductive arguments are here. Before you try to figure out which is which, I want to use this diagram in hopes of helping you have a structure for determining which is which. So what you want to do is come down to the argument rests on chain of reasoning. And that chain of reasoning are its premises, right? And sometimes there's one, sometimes there's two. Both these arguments here have two premises. And the question you want to ask is, does this conclusion, right, follow necessarily the premises, right? If it doesn't, it's probably an inductive argument, right? If it does, it's probably a deductive argument. So think about this. All birds have feathers. A penguin is a bird. Therefore, a penguin has feathers. All right. So is this inductive or deductive? Well, all birds do have feathers. Even flightless birds have feathers. A penguin is a bird. Okay, we agree with that. A penguin is a bird. Therefore, a penguin has feathers. If this is true, this has to be true, right? And here's the kicker. If this were not true, then this would not be true. If this said something different, if it hedged or in any way was not all, see, that's the key word there, then we would not have a deductive argument. And you probably guessed by now that this one's inductive because obviously I would try to have an example of both, right? So every penguin I've ever seen has had feathers. This animal is a penguin, therefore this penguin has feathers. Now, the qualifier here that makes it not necessarily follow that this penguin has feathers, right, is that every penguin you've ever seen, all right? There may be penguins out there without feathers, you just haven't seen them yet. Whereas this makes a inclusive claim that that includes all birds have feathers, and this one is exclusive or qualifying. Every penguin I've ever seen has had feathers, right? This animal is a penguin. We would probably agree on that, but whether this penguin that we're about to look at has feathers or not is not 100%. Maybe a pretty good probability, but it's not 100%. For the longest time, good example, for the longest time, Western Europeans thought all swans were white. You may think all swans are white. I thought all swans were white. However, when they colonized Australia, guess what they found? Black swans. So I didn't know black swans exist, but they do. Therefore, if someone said all swans are white after that discovery, they'd be incorrect, and the argument would be wrong that all swans are white. So anyway, this is a case of that. All we can say for sure, unless we know we've seen every kind of whatever it is, a swan, whatever, is that all the ones we've seen are this, that, or the other. And that makes it an inductive argument. All right. There are types of deductive and inductive arguments. So, and as you'll see, the deductive are more structured. They're more anchored in areas where we tend to use facts in how we process information, not probabilities. So in mathematics, definitions, categories, hypotheses, and we'll get to this disjunctive syllogism. So here's an example of a deductive argument. Meerkats are members of the mongoose family. All members of the mongoose family are carnivores. Therefore, it necessarily follows that the meerkat is carnivore. This is a categorical deductive argument, and you can see why, right? So the meerkat is a member of a category, mongooses, and all members of mongooses family are carnivores. So meerkat is in a category. That category has this attribute, and therefore it is a categorical deductive argument. Under inductive arguments, we have predictive analogy from authority. So this is someone who is recognized as an authority making a claim, or a book recognized as authoritative, that sort of thing, based on signs, and causal inferences. These are all, well, I mean, they're just squishier, right? I mean, they're just squishier because they are not out of categories. They're not being categories. They're not in elements that are fixed in fact. Causal inferences are causal inferences. We think that's what causes it. We may know so far that that's what causes it, but that doesn't mean it's always going to be that way. But the more times we know that that something causes something else, the more times we know it, the stronger our inference gets, the stronger our inductive argument gets. The meerkat is closely related to the suricate. The suricate thrives on beetle larvae. Therefore, probably the meerkat thrives on beetle larvae. Now, this is an analogy, right? You're making an analogy between the meerkat and the suricate. And the suricate is got a particular attribute, and we're assigning that to the meerkat. So it's an analogy. This is like that. Pretty straightforward. All right. Lord. I'm going to turn this thing off. All right, back down here. All right, so these are examples of types of deductive arguments. All right, so you have categories, which the Mercat example was, hypotheticals. So this is a statement that if these two things are true, this will be true, even though it's a hypothetical. If it rains, the ground will be wet. If the ground is wet, the game will be canceled. Therefore, if it rains, the game will be canceled. This is an absolutely deductive argument, even though it hasn't rained, right? We're making a prediction about the ball game this afternoon. But we know that this reasoning, these premises do necessarily point to this, because both of these premises are true. Now here's the good old disjunctive syllogism. Either we go out for dinner or we cook at home. It's an either or. So the argument would be, are we going to eat out or are we going to cook at home, right? And we're going out for dinner, therefore we don't have to cook at home, right? Pretty, disjunctive syllogism's almost overselling it, right? It's just an either or case. Think of it that way. Here's one based on math. The result is always even if you add two even numbers. Premise 2, 4 and 6 are even numbers. Therefore, 4 plus 6 equals 10 is even. So you see it's number oriented. It could be angles of a triangle, or that would be related to math, that sort of thing. All right. Here's some inductive categories. We did analogy, right? Medical trial participants who took drug A recovered faster from the flu. You are similar to those. So an analogy, you are like them. Therefore, you should take drug A because you'll probably recover faster. Now, it's not absolutely for sure because we don't know. You weren't in the test, but we're basing it on similarities. Authority, Dr. Smith, a well-known, a well-respected climate scientist, meaning that his peers respect him, says global temperatures will rise by 2°C by 2050. Conclusion, global temperatures will likely rise by 2°C in 2050. Now, we've not been through climate change before as a species, so we are using models based on science that make sense to us, and there's every reason to have confidence in Dr. Smith's prediction, but we don't know it for 100%. We've not gone through this before. There are some things we know about how the climate behaves, and we can use those with confidence, particularly if we're Dr. Smith, who spent our lives doing that. You ate undercooked chicken last night and now have food poisoning. Eating undercooked chicken likely caused your food poisoning. All else being equal, if we go out to eat and you have chicken that's undercooked and I have, sushi, which is not cooked at all, and you get sick and I don't, then it's probably, and everything else we had was the same, then the causal inference would be an inductive argument that the chicken caused your illness. And prediction, it has rained every afternoon this week, therefore it's likely to rain this afternoon. It's actually a weak inductive argument because we don't really know enough to make that kind of prediction. Just because it's rained every afternoon may have nothing to do with this afternoon because we don't actually understand why it's raining, but it is predictive. And we do base things. If we had more information about the atmosphere in the afternoon and what how it has been the previous days this week, then we can make a better inductive argument here. But that's a predictive inductive argument. All right. So there are a series of exercises here that I want you to go through that will help you understand whether an argument is inductive or deductive, and well, I guess I have to take you through them, don't I? Because this is a video. Duh. Okay, here we go. All right. So this is kind of similar, right? Singh is an expert in climate science. He stated temperatures rising. Given her extensive research and expertise, it's reasonable to accept that claim. Believe the claim is accurate. It's reasonable, but it's not definite. So what would that be? That would be an inductive argument, and it's an inference from authority. That makes sense, right? All right. About 80% of the customers I surveyed at the bookstore said they preferred hardcover books over ebooks. Since I'm targeting readers with my new publication, I predict most of them will prefer hardcover editions. All right, so 80% in the survey that he took preferred hard copy, and his conclusion is that he should publish hard copy editions of his book. That's inductive, and it's a statistical generalization. All right, so we haven't covered that type yet, but it's when we use we anchor an inductive argument with a number, a probability, right? It's a probability argument, but it's also a statistical generalization, right? Because here's a statistic he took from a bookstore that he surveyed, and he's going to generalize to the whole public, right? See the generalization there? It's statistical generalization. All right. All mammals are warm-blooded. Dolphins are mammals, therefore dolphins are warm-blooded. Now, do the premises necessarily lead to the conclusion? They do if they're true. Therefore, this is a deductive and categorical syllogism. It just means categorical argument. Don't worry about the syllogism part. Deductive, and it's categorical. Last time I studied for my philosophy exam using flashcards, I aced the test. Since I have another philosophy exam coming up, using flashcards again will help me succeed. Deductive or inductive? Well, it is true that he did that. However, what's this word here? Likely, right? Likely. These type of words, look for these. You know that you've got an inductive argument. And it's inductive by analogy. He's comparing this upcoming time to being like this time. Now, he's probably right. I mean, not just because flashcards are a good way to study, but, you know, everybody studies a different way. He knows that flashcards work for him. So this is probably a pretty good inductive argument, but it is inductive. It's not something that can be proven. Either a package will arrive today or it will arrive tomorrow. The package did not arrive today. Therefore, it will arrive tomorrow. Okay? So that's a deductive, disjunctive argument. Syllogism thing, I should have taken those out of the slide. My apologies. So see the or here? Remember that the disjunctive syllogisms, the disjunctive deductive arguments are either or arguments. They've just dressed up in big words, right? Okay. It rains. If it rains, the picnic will be canceled. It is raining, therefore the picnic is canceled. So if it rains, the picnic will be canceled. It is raining, therefore the picnic is canceled. These are the premises. Do the premises necessarily follow this? Well, in fact, they do. This is a conditional argument. It's an if-then argument. So think of it that way. You're going to have to go back and study these and really make sure you understand the definitions. And like everything we do, what we're doing is building on itself. So make sure you get these down. I mean, don't blow through them just because there's just a couple of them and maybe 5 different types on each side. Get a good grasp on them, because these will be coming up on the quiz and you'll be doing some of this delineation on your own. All right. Goodness. If the train is on time, I will arrive at 8 p.m. I did not arrive at 8 p.m., therefore the train was not on time. Okay, if the train's on time, it'll arrive at 8 a.m. That's what the schedule says. It did not arrive at 8 a.m. Okay, those two things would necessarily lead to the conclusion that the train was not on time. That is a deductive conditional statement. If then, right? If then. Conditionals are if thens. We studied that in the first module that we did logic basics in. All right. Smartphone sales have consistently risen 15% annually for the last 5 years. Therefore, it's likely that smartphone sales will rise that way this year. What's going on here? Likely word. So we know it's inductive, right? But what kind of inductive argument is it? It's prediction based on trends. You could argue that it might be a statistical generalization as well. But it is a prediction based on these past trends. So I think this is the right category. Whereas the statistical generalization is the 80% of this, then probably that. Not a trend line that involves years. So this is prediction based on trends because of the past 5 years, 15% annually. That's the trend, right? You see the trend there. It's an inductive argument based on trends. Okay. If a triangle has two equal sides, it's an isosceles triangle. This triangle has two equal sides, therefore it's an isosceles triangle. My 5-year-old grandson knows these. I barely know them myself. I wasn't that good at geometry. Obviously, he's smarter in that area than I am. Well, at 5, I'm okay with that. Not really. Okay, so if a triangle has, what is this? These two premises necessarily prove this. Therefore, it's deductive and it's mathematical. Remember I mentioned before that the mathematical one about even numbers we were looking at could also be, and that could also involve things like triangles. All right, all bachelors are unmarried men. John is a bachelor, therefore John is an unmarried man. All right, these premises do naturally lead to the premise or to conclusion. So this is a deductive argument and it's definition based. Remember, one of the categories was math, science, definition. This is definition based because it's based on what the definition of a bachelor is. Every day this week, the cafe near my office has been crowded around lunchtime. Based on this pattern, I believe it's safe to assume the cafe will also be crowded tomorrow at lunchtime. Pretty good bet, I would say. It's not absolute, but it's a pretty good bet. Therefore, it's inductive, and it's a generalization from experience, right? And again, you're not going to get asked for these fine-tuned like generalization from experience. This is just would be in a generalization category. So that is what you need to understand. We've seen trend, we've seen statistical generalizations. Now you see a generalization from experience. Every time I water my plants daily, they thrive and grow. Since I recently got a new plant, I'm confident that I'll water it. If I water it daily, it will also grow well. So is this inductive or deductive? Every time I water my plants daily, they thrive and grow new leaves. Since I recently got a new plant, I'm confident that it will go. It's not 100% because not all plants respond to water, right? So it's causal. There's a causal inductive argument here that because I've watered plants and they thrive, I should water my new plant. Well, not if it's a cactus, but we're assuming that he or she would know, so it's inductive causal. All right, so that gives you a taste of deductive and inductive. You could play back this video to get more practice at those arguments. You could also ask ChatGPT to run you through the traps. I mean, ask ChatGPT to give you some examples of the types of inductive and deductive arguments. It's a perfect use for the AI because it's a relatively simple task. It's a relatively simple definition. There's little less area for error on the AI's part. And it's, ChatGPT is a free account. You can go out there and use it. You will run out of capacity at some point if you use it a lot during the day. But I practice myself. I test myself on certain things using ChatGPT, and so far it's done me pretty well. So that'd be my suggestion. You do what you like to do, and I hope you have a good week. And I will see you next week.